today we'll be starting off with the physics of grade 10th, and the first chapter that we'll start off with is electricity. The target for this series of videos that we are bringing for you is to make sure that we revise the topics that are very important from the perspective of boards, plus also we'll take up some very interesting and important questions that are very much probable from the perspective of boards, that is upcoming board exams. Now, starting off, the very first topic that you guys are introduced to when we start the chapter electricity is current, electric current. So we have to understand that what exactly this term electric current means in physics. I have the definition with me. I'll go through it and then we'll proceed further to understand that how the question can be framed from this. First and foremost, what is electric current? The electric current is defined as the net amount of charge flowing across the area. Now sir, which area they are talking about? Now see guys, if we talk about one wire and let's suppose take one small element of this wire and zoom on into this. Now when you zoom in onto this is how the wire will look like. Let's suppose we take out the top layer of this, and inside this is basically this circular part that you see is nothing but the cross-sectional area that we talk about. So they are saying that the net amount means the total amount of charge that passes through this cross-section area in the time interval delta t. Now let's suppose, understand it like this. If I am standing right on the top of this part, right, and I say that let me count how many electrons are basically passing. So the number of electrons, let's suppose I start to count, and I say that let's suppose I start my watch and I count that 100 electrons have passed in 10 seconds. So if I know that sir, total number of electrons, how many are passing from here? 100 electrons have passed in 1 second. So you can figure out that sir, what is the total charge? Now sir, how can we do that? See, basically students understand one thing. The moving charges or the charge particles that are free to move are only one and only electrons. Protons or neutrons will never be flowing. So you have to be very clear and very perfect with the fact that electrons must be passing through this cross-section area. I have to count it. Now I count that sir, I get a number of 100 in this example, or for an instance let's take a general number. I say n electrons are passing. How many electrons? N electrons pass in t time. Now, the total current is defined as total charge divided by time. Now, if you ask me what is the total charge, let's suppose the charge on one electron is E, the total number of electrons is N. So, as simple as that, if I know, I'll give you one example, that let's suppose sir, I know that there is a bag. In the bag there are small packets. Now, if I tell you that there are 5 packets, each packet has a mass of 2 kg. And I ask you that what is that mass of the total? You can say sir, total number is 5. So 5 into 2, 10 kg will be the mass of the entire bag. So similarly, if I know that on one electron, what is the charge? 1.6 into 10 to power minus 19 coulomb. This is something that you guys have to remember, that if ever we are discussing about electrons and the charge that is basically there on the electron, sir, how much charge is basically present on this? It is nothing but 1.6 into 10 to power minus 19 coulomb. This must be on our tips. Now, if this much is the charge on one electron, sir, can I say the total charge will be nothing but N times E divided by T. So this is also one formula. Students often neglect this, but remember the formula of current can be written as I is equal to Q by T. Q can also be written as number of total electrons multiplied by the charge on one individual electron, right? So final formula is Ne by T if I talk about electric current. Now, this is one way and one of the methods where they can ask you and frame a question out of. We'll be taking up one numerical on this as well in the upcoming classes. Moving on to the next part. They can also ask, now see, students, try to understand. Every one of you probably must be remembering the definition, right? The total charge that passes in time t, or you can say per unit time, the total charge passing per unit time through the cross-section area is electric current. Now, most of you remember this. But there can be a little bit tricky question that can be framed out of this topic, and rather than asking you the definition of electric current, they will ask you that define the SI unit of electric current. So students, understand and learn and remember this, that if we are asked to define the SI unit of electric current, now I hope every one of you remember that what is the SI unit of current. So remember students, the SI unit of current is nothing but ampere. Now sir, how can we define ampere? See, the definition of ampere will also come from the definition of what you learned for current. Now if I go one by one, you have to understand that the total charge if it is 1 coulomb and total time if it is 1 second. If total charge is 1 coulomb and 1 second is the time, I think if you put the value in the formula, you will realize that I will be equal to 1 ampere. Total charge Q, that is the charge that is passing through the cross-section area in 1 second. If he says that 1 coulomb is passing in 1 second, then we can finally further state that 1 ampere is the current in the wire. So please remember, as much as important this definition of electric current is, same way the definition of 1 ampere is also very important. Remember it as it is, link it with the formula. That's if I put the value of charge as 1 coulomb and time as 1 second, eventually the value of current will be 1 ampere. That's it for today. We'll be taking up some numericals on this in the next class. Thank you so much.